everyone, welcome to this week's News and Community Spotlight. Award-winning digital designers Painting Practice used Unreal Engine to help directors and producers plan vast sets and key action sequences on the hit fantasy TV series His Dark Materials. Watch our spotlight to see how real-time visualization helped them explore the conceptual environments and get up close and personal with a CG bear fight. This June, prepare to jump into your tactical kayak in Phantom Covert Ops, an innovative take on the stealth action genre for Oculus Quest. Developer nDreams prototyped the VR stealth shooter as a way for players to naturally explore in VR while avoiding simulation sickness. In the meantime, sneak over to our blog where nDreams shared how they iterated to achieve realistic yet accessible gameplay mechanics and their VR-centric approach to UI design and optimization. Holographic computing will transform how we work, play, and collaborate. Soon, people from all walks of life will be able to gather around a table and interact with the same ultra-high-fidelity digital 3D hologram. The live Apollo 11 demonstration showcased this technical capability with HoloLens 2 devices. Now, venture further into the groundbreaking Apollo 11 demonstration to see how the high-quality mixed reality experience was created in our spotlight on UnrealEngine.com. If you missed our webinar on working collaboratively in Unreal Engine, the replay is now available on the Unreal Engine YouTube. The webinar focuses on the multi-user editor and the Collab View template, which empower you to work simultaneously with other team members, leverage virtual scouting tools, and more. As always, we'd like to give a big shout out to our top weekly Karma earners: Clockwork Ocean, Every Nun, Bama Game, Ira JSB, Mindsurfer Dev, Shadow River, Black Force Dragon, ADCA Dev, Paperbag, and Beano. Thanks for supporting other UE devs on AnswerHub. First up on our list of community spotlights is Rider for Unreal Engine by JetBrains, a powerful and fast IDE with a deep integration to the Unreal Engine toolset. Rider accommodates Unreal naming conventions, its code navigation and generation actions handle UE4 remote procedure calls, and it also reads blueprints from your project. Rider is available for public preview. Visit their site to try it today. Inspired by Final Fantasy VII Remake, Ryan recreated these Materia Orbs, the source of magic in the game, with his own twist, using Houdini, Megascans, and Substance Designer before finishing in Unreal Engine. See this and more of his work on Ryan's ArtStation page. 3D action platformer Protodroid DeLTA is set in a solar punk world with a hopeful yet non-utopian vision of the future, and influenced by classic SNES games. Play as DeLTA, a protodroid, as she fights to save the Radia region from the devastating drone gang threat. Along her journey, DeLTA will forever change the lives of every person she encounters as the story unfolds. Follow the action on their Steam page. That's all for this week. Thanks for tuning in.
Hi everyone, and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Victor Broden, and today we are going to cover a little bit about the 4.25 update of Unreal Engine that is about to go live soon, real soon. Together with me today, I have Simon Tourangeau, Mr. Jean-Michel Dignard, James Golding, down in the corner, Lauren Delane, right behind me, and Mr. Marcus Wasmer. Welcome so much to the show. Thanks for coming on, taking a little bit of time out of your day to talk to us about what's coming in 4.25. I would like for us to kick off with James Golding, and please give us a little rundown on what you're going to cover today.
Sure. So I'm going to talk very briefly about the Chaos physics engine, where that's at, and some updates for 4.25. And then I'll talk a little bit about Unreal Insights, which is our profiling tool. And there's some really exciting improvements there, not just the core tool itself, but also some of the things we're doing with it and planning to use for other things. So I'll get started on that. So chaos. The big news around chaos over this sort of last period was that we've now shipped it in Fortnite. That was sort of made quite publicly. So we've shifted the game over, and that was a really useful process to shake out a lot of bugs, do a lot of optimizations, really test how well the system does in the wild, in a real game that puts under a lot of pressure. So that's been super helpful. Of course, all those fixes and improvements are in 425. So it's still off by default, so it won't be in the binary build. You will need to get the source code and build it yourself to turn it on. It's not something that you can switch on the fly. But we now consider some parts of chaos to be production ready. So things like scene queries, that's raycast, sweeps, overlap tests, that whole system is now really fast, and we consider that to be production ready. The rigid body dynamics, so things like if you build vehicles, just creates parts of the scene where you normally use just simulation, straight up rigid bodies. We think that that's pretty robust now. Rigid bodies on characters, so the rigid body anim node that's available in the animation system. So for sort of ponytails and flappy objects on characters, that's pretty solid. And then the clothing system as well. We use Chaos Cloth inside Fortnite, so that's been getting a lot of testing as well. So we think that all of those features are something that you could definitely switch over to if you're in a position to do that, or at least start experimenting with it in 425. Still being worked on is the field system in Chaos, which allows you to sort of set up volumes and apply forces and different sort of physical parameters within certain regions. The destruction system that we showed last year, that's still something which is not fully production ready, but is continuing to be worked on. And we've also shown recently some work around hair rendering and simulation. So there's the Chaos hair simulation there is again something which is still being worked on. It's really exciting stuff, but obviously hugely challenging, and we'll be continuing to develop that. Ragdolls at the moment, ragdolls in the scene are not implemented on Chaos, so that's kind of one of the big things we're working on for this period, to be bringing 420, bringing Chaos as sort of an on by default, the default choice of physics engines. But we're working really hard to get there. We're very excited to get to that point. I just saw a question come up about Chaos Cloth. So just to be clear, whereas before we used PhysX was the physics solver, and that did rigid bodies as well as cloth sim, and so we're switching everything over to Chaos. So it will be a complete replacement for all of those pieces. So in Fortnite right now, we're using it both for scene queries, we're using it for physics simulation for things like vehicles and rigid bodies on characters. We're also using it for cloth on characters. So there is a new cloth solver as well. Okay, so that sort of covers where Chaos is at. Lots of work and really exciting. We're really looking forward to being able to integrate physics really tightly into the way the engine works. I think there's a lot of exciting things we'll be able to do there. The other thing I wanted to talk about was Unreal Insights. So that's our profiling tool. It can capture a lot of information really quickly and process it really quickly. One of the great things about it is it can open long captures with lots of information, and it still is really responsive. So they've continued to work on the sort of UX experience side of it. So it uses a separate process to make it really fast, not interfere with other things that are going on, and the way that the data is organized. So we already had the ability to capture sort of timing information from events, so you could see what was going on during your frame. But now we've added a couple of extra things. So Network Insights is one of those where it's supposed to be, I don't know how many people are aware, but there is an old C# network profiler tool, which is actually still pretty useful. You can do a capture from an Unreal project and then look at that to figure out what objects are replicating state, sending information over the network, and how much, where is your bandwidth going. So it's useful, but it's very long in the tooth. And so Network Insights is designed to be part of this Unreal Insights suite of profiling tools and debugging tools. And so it's not completely at parity yet, and it's still experimental, but it's already pretty useful. So you can capture a lot of information about the network packets, see what objects are using bandwidth, and it's written in Slate, so the UI is consistent with all the rest of the Insights tools, really fast, and sort of uses a lot of the same pieces. So we think that's going to be a really interesting, really useful tool. And we're looking at lots of other places where we can start to bring debugging and profiling tools together into this kind of Insights suite, which segues nicely into, I'll pass over to Laurent, because one of the really exciting things in 425 is animation insights. And I'll let Laurent say a lot more about that. Let me just see if there's any other questions before I hand off. I'll read through these in a minute, and I can answer those later or answer on chat.
Yeah, we'll go for a little Q&A at the end there.
Sure thing.
Yeah, so we'll transition to animation updates. We'll start with animation insights to go off after what James said. I have prepared some slides, and I will share my screen because I thought it would be more interesting to try to show some of this in action. So hopefully everybody can see that.
We see it.
So Animation Insights, it's part of the Unreal Insights suite of tools. And with Animation Insights, you can record and playback all things around animation. That state is called trace data, and we capture multiple things. For example, we'll capture poses, animation curves, blend weights, and so on. And all of this data is displayed on the timeline as different tracks. So you'll have pose tracks, curve tracks, and so on. Because it's on the timeline, you can, of course, scrub, rewind, and playback that data that has been recorded. And these different tracks, you can filter them. So there's an illustration on this side that you can see what it looks like. As an example, here's a pose track. So we recorded a character running around in a level, and we're playing that back inside of Animation Insights. So as we scrub the timeline, we can see what pose the mesh was in, where in the level at a given time. Like as I said, we record a number of things. To illustrate that, on the left, this is the blend weights of an animation graph. So as we scrub, we see which parts, which nodes, and which branches of the animation graph were active at that time. And on the right, it illustrates some of the more custom recording, but also display that we have in the system. So in this case, it's a blend space. We record the input to the blend space, and as we scrub, we can see exactly where it was and how it was impacting the different samples of the blend space node. We've also added a special view that we call schematic view. And this replaces the system that we call show debug animation. That name referred to the command line that you had to type in the console to summon it. And it would draw a flattened tree view of your animation graph on the canvas. So this is similar, but instead it's built inside of Insights. So as you scrub on the timeline, which you can see on the left, the view updates in real time on the right. And what you see is a picture of your animation graph. So it's still a flattened tree view, but it shows the state of the graph at that point in time. That means that we'll take into account everything dynamic, such as if you're using montagers or if you linked animation blueprints dynamically to your main animation graph. And then you have a lot of neat things on top of that. There's a search, for example. So you can use that to filter out only certain type of nodes you're interested in, certain assets, certain properties. The property that you see displayed on the column on the right is the weight of the nodes. In the view options, you can display a lot more things. So we capture a lot of data. You can see the play rate, the position. So you can customize what's visible. This is also dynamic. So if you write your own custom nodes that will inject new data, it will be picked up here and you'll be able to display it, filter it, search it, and so on. That view is also linked to the animation blueprint editor. So you can click on any of these nodes and it will take you in your graph to that same node. There's a couple of interesting filtering that's worth calling out on top of that. On the left is what we call channel filtering. And that's basically what gets recorded to your insights file. Let's say you're only interested in bone transforms, in poses. You don't care about networking, you don't care about performance, you don't care about any notifies. So you can really customize what gets recorded. That helps not only what you see when you play back on your timeline, you have less tracks, but it also helps you keep your file smaller. So eventually we'll have a lot of data and that will allow you to record what you need and keep that file small enough. On the right side is what we call source filtering. And that's basically what you have recorded is to filter out what gets displayed in the end. So let's say you recorded the pose of a character and you were playing Fortnite. You could have 100 of these characters on screen. It's a lot of bone transforms and you want to filter through that. So that allows you to create little pieces of logic to filter which actors will be displayed or not. And that you can write in blueprints. So you can create lots of pieces. You can combine them with simple Boolean logic. So you can do A and B and not C. And you can promote that to a preset. So it's something you can share with other users. And if it's a common workflow, it's not something you have to recreate every time. So combined, this is extremely powerful. If you're working on a specific feature or you're trying to track down a specific bug, you can really customize the data that you need, and you can share it with others. If you need, in a game like Fortnite, you may need a QA to help you reproduce a problem. That helps you do that. And that wraps up animation insights. The next piece that we want to call out is control rig. We've made a number of improvements to control rig this release. A number of these focus on improving usability and lowering the barrier of entry. And I'll show a few examples of that in a minute. Next is Python scripting. We have full Python scripting support in control rig, and you can use that to automate workflow tasks. So for example, if you're trying to replicate a complex RBF setup that you have in Maya, you can automate that to create it in Unreal and keep them in sync instead of having it to do it by hand, for example. We've also added a new auto-compile mode, which performs fast compilation for any change that the user makes. So the user gets instant feedback and can stay in the flow while working on the rig. We've also re-implemented the control rig backend using a new virtual machine, and that led to some significant performance improvements. So now to highlight a few of the usability improvements. The first one is visual debugging. When you work on your rig in a node graph editor, you can already right-click on the pin and select watch this value. And that will show a numerical display above the node graph. Now there's a new option, and you can add a visual debug. And that will create a visualization in 3D in your viewport. There's lots of options, and you can customize it. In this example, the user is moving a control that drives an aim node to orient the head of the dragon. And what the user wanted to do is to create a lag effect. And so we're basically lagging the position of that control, and we added a visualization to see exactly what is happening there. This is something that's completely data-driven that you can add to any node on your graph, any pin of any node in your graph, and you can enable and disable them at will. So as you work with really complex rigs, you can build pretty advanced and useful debugging features into it. The next one is to control pin values. So in this example, we have an IK solver, and we want to set the translation of an effector. And before, you had to manually type in the value and try to guess something that made sense. Now you can just right-click on that pin and select control pin value, and that will spawn a gizmo in your viewport, and you can drag this around and use it to set the value. So you can do that now visually and not doing typing by hand and trying to guess. The last feature we want to highlight is limits on controls. So when you have complex rigs, you can have a lot of controls and you're trying to design your control boards. Limits allow you to make sure these controls are constrained within a range that makes sense. So here we have a vector 2D that's driving the rotation of the heads. That's something that works for other types as well. So if you have transforms and floats, you can also set limits and have a nice constrained control board for your rigs. That's it for control rig. The next one is something I'm very excited about. It's animating in engine. And that brings control rig and sequencer together to enable users to animate inside of Unreal. So you don't have to leave that tool and go to another app. The process is really simple for that. You build your rig in control rig, and you expose controls that then you'll use to animate. I have a video that illustrates that. Once you've done that, you can drag and drop your control rig in a level viewport. And that will create a level sequence, open up sequencer, and it's ready to go, literally. All your controls will be exposed, and now you can use sequencers, manipulation, and curve tools to start animating. Once you've done this, you can bake the animation and export it as an animation sequence, and then use it in the rest of the animation pipeline. Sequencer also has additive layers, so you can work in a non-destructive manner and tweak an existing animation. So we've taken this dragon from the marketplace, and we've given that to one of our animators, and he spent a couple hours working on animation, and he came up with that in the end. And it's just really exciting to see the things that you can build inside of the engine now. Next, we've done some refactoring on our animation asset editors. We tried to unify the look and feel between that and sequencer. So we've done this for the timeline of our animation asset editors. Also, the animation curves now use a similar curve editor. And again, you'll find a lot of the tools that you're used to for manipulating curves. We've also given a makeover to the montage editor, and specifically how you work with sections. So now there's a breadcrumb trail editor, and it's a lot easier to work with. Finally, the last thing that we want to highlight are some improvements in animation compression. Our animation compression, or codecs, were written in C++ and hard-coded. Now we've pushed this into data assets, and we've also added support for plugins, which means that now it's a lot easier to use external animation compression schemes. An example is the animation compression library that Nicolas Frechette is working on, and is extremely popular. So now you'll be able to use that a lot easier in the engine. These compression setting assets also can support multiple codecs. So before we had this concept of automatic compression that would run through a bunch of compression schemes and make sure to pick the most efficient one given an error threshold, making sure quality is acceptable. It's illustrated on the screen there. Now you can do this in assets, so you can do this in a data-driven way, and you can customize it. Finally, animation compression is now asynchronous, and so it's performed as a non-blocking operation inside of the editor, so you can keep working while your animations get compressed as a background process. So that helps productivity quite a bit. And that's it for the animation updates.
Thanks very much, Laurent. Let's move on to Simon next.
Yes, thanks. So we've been working on a set of mesh editing and sculpting tools, a little bit like we want to do with the in-engine animation. We want to be able to model inside the editor to reduce the need to cycle with external DCC tools, make it easy for level designers to build rapid models and block out their levels. Victor, are you showing the examples? Live. Okay. So if you want to use this, you must enable the plugin. It's called the Modeling Tools Editor mode. You see a few examples here. We have the Poly Edit tool, where you can easily manipulate the objects by manipulating faces and edges and extruding, and build this small tower pretty efficiently. We have the Polypath tool that you can use to draw walls and ramps with constant width. It's just great for blocking out levels. We have a tool to transform UVs, so you can rotate, scale, and translate UV islands on meshes. And we've been working on sculpting a lot. The goal is really to be able to sculpt high definition models, and we have an example with using high resolution quicksole scans We gave that to one of our artists, and by combining dynamic mesh sculpting with world space trilinear materials, with the Quixel scans, he rapidly built a fully 3D mesh component that integrated very well in the landscape. And if you're seeing the bridge now, there's no displacement here at all. It was modeled directly, and pretty amazing the result we can get. This is still experimental. We're working pretty hard on adding new features, and hopefully soon we'll not need to go to external DCCs too much. Next, I want to talk about our high-quality media export. That's a successor to the sequencer render movie feature. It's built for higher quality and easier integration into production pipelines, and it's much more extensible for users. So with this this new module, you can accumulate multiple render samples and to produce your final output frame. So you can have much higher quality anti-aliasing, radial motion blur, can reduce noise and ray tracing. And it supports several other new features for high quality renders, such as with the high resolution setting, you can overcome the GPU memory limits and device timeout, so you can make huge high quality renders. You can export translucent images, 16-bit HDR images, and one cool thing is you can save your render configurations into assets so that you can reuse them and share them between developers. So pretty cool tool for saving out your cutscenes and sequences. Next, I want to talk about in-camera VFX. UE4 has been used more and more in the movie and TV industry, and you might have seen the demos that we had at SIGGRAPH, might have seen some of the shows that we've done with that. So a lot of that is based on nDisplay, and we've improved nDisplay a lot. So we now support multiple cameras, multiple camera frustum at the same time, shooting on the wall. We can control the frustum resolution. We have green screen tracking markers, and we simplify the 3D layer comp setup. Those are all very, very complex uses of UE4, but you can look for an in-depth white paper that will be available in the UE4 doc soon, which explains how to use all this with nDisplay. One last quick thing, a nice feature that was added, still experimental. We have a disaster recovery plugin that keeps track of everything going on in the editor, keeps every transaction. And in the event of a crash or power failure, mostly, since we don't crash, right? It can replay events and get you back to the point you were, so you don't lose work. Works pretty well, still experimental, but highly useful to make sure you don't lose time. That's about it for me.
Thanks, Simon. Chat's definitely very excited about the sculpting tools and the editor ones as well. And so it's exciting that we're able to share that. Would like to move over to Jean-Michel.
Yeah, so I'll cover some enterprise use cases. The first one is a new plugin that we have shipping with the engine. It's called the LiDAR Point Cloud. If you can start the video, Victor.
It's live.
So the LiDAR Point Cloud, what it is that you can scan real world using the LiDAR method, which is basically a laser scanner. In the video that we're showing, there's around 300 million points that have been scanned. So this is a mining site. We've had an official plugin since 4.24 on the marketplace. We've improved it, and now it's shipping with the 4.25 engine. So it supports different text-based formats. so txt, xyz, and .pts. And it also supports the LAS file format, which if you're using LiDAR scanners, it's the format that you might be familiar with. It's also it's asynchronous, and it's streaming the data. So LiDAR point cloud datasets can be very big. So there's a dynamic LOD systems, and it's gonna stream exactly what you need to the GPU based on different budgets that you set up. The points can also cast and receive dynamic shadows. You can visualize your data using multiple coloration techniques. So as you're scanning, you're gonna get the RGB colors for whatever real world that like either you're scanning a terrain or you're scanning buildings, you're gonna get the colors, but you can also display the elevation of your data and other coloration techniques. You can also edit your point clouds. So we have an editor where you can select different sets of points. You can add them, delete them. You can extract them to create other point clouds assets. And finally, you can also create collisions based on your point clouds. So if you need to interact with the Unreal physics system, like have stuff walking on your scan terrain, you can generate the collision and then have your pounds collide with it. That's it for the point cloud. I'll share my screen for the other updates. So the other thing that I want to talk about is visual data prep. Visual data prep is used to get your CAD data, your BIM models, or your big enterprise data sets into Unreal, where you will need to apply operations on them, create collisions in batch, do batch lightmap UV unwrapping. So this is a tool that you would use. We've improved the UX in 4.25. We've added filter preview and new filters and operations. So we can now filter your objects by layers, by vertex count, by triangle count. You can add offsets to your actors. So if you have a lot of actors that are all lined up perfectly, maybe you want to add some noise to them. You can also flip triangle faces. If you're working with CAD data, having your tessellation might generate triangles that are backward facing. So you could write a data prep pipeline to flip those. And you can also substitute assets. So if you have an architecture scene that's coming in and you want to replace all the trees, it's something that you can do through the visual data prep tool. So this is the new UX. On top, we have the 4.24 version, which was more like a blueprint type of graph. In 4.25, the UX has been improved to highlight that the tool is multiple stacks of operations that are executed one after the other. So you get to snap your operations on basically the execution line. You can either copy them or just move them. You'll be able to drag and drop filters and operations, and they will snap exactly where they need to be. So this is the filter that's moving around. So as I said previously, you'll be able to preview the filters. So let's say you want to get all your meshes that are over 50,000 polygons. You'll add your filter, you'll add your criteria, and then you'll be able to preview them a bit like you can preview material expressions in the material editor if you're familiar with that. So you will see which meshes are corresponding to your filter. Next is our support for universal scene description. Since 4.24, we've been working directly with .usd files in Unreal in a native way. This is useful, especially for VFX pipelines. So in 4.25, we've updated the USD SDK. We've had issues in the past reading files coming from other DCC where they had a newer SDK version than we did, so that should be resolved. We've also added support for pointed sensors, Udin textures. You can assign your Unreal materials to your USD meshes. We've added support for USD purposes, so you can choose if you want to load your proxy meshes, your render meshes, or your guides. If you have custom USD schemas, you'll also be able to hook them through our system so that when we read the USD file, we'll call you back and you will be able to process those specific schemas. We've also multi-threaded the stage loading, so it's around 4 times faster on our test, but it's going to scale differently based on the number of cores that you have. And finally, we've added support for USD on Linux. If you're also looking forward to USD on Mac, that has hit our GitHub branches. Unfortunately, it didn't do the cut for 425. So this is an example of, hopefully the GIF will play, of the Houdini Solaris demo scene. So basically, this was authored in Houdini. You can load it directly from the USD file in Unreal. You'll be able to inspect all your data. Also, a new thing is that you'll see all the USD attributes in there, so you can see exactly what are the different values. In this particular scene, all the materials are mapped using Houdin textures, and the jars on the back are all spawned using point-end sensors, which is the equivalent to Unreal HISM component. So that's it for USD. Another hot topic is editor performance. So we've made a lot of improvement to editor performance as we do for each version, but especially for 425, what we've worked on is distributed shader compilation. So if you're using a distributed system to compile your shader, the overhead of spanning a bunch of shader compilers has been improved quite a bit. We've also optimized a lot the HLOD generation. Basically, 2 algorithms that are used in the background when generating HLOD. It's material baking and proxy mesh generation. Both of them have been optimized heavily. We've optimized distance field generation, which when you build your static meshes, it's something that you'll encounter. We've also did a lot of optimization around convex hull collision generation. Another thing that we've worked on is exporting videos to PNG. So if you were using if you're exporting sequencer videos to PNG on disk, that was a slow process before. It should be a little better now. Also, if you're working with a lot of CAD data in your level, saving and loading those data sets will be much, much faster in 425. And finally, the data symmetry import process is around twice as fast in 425 than it was before. So these are some of the timings that we've measured. We've normalized all the time. So 424 is basically your benchmark set at 1. And HLOD is now 4 times as fast to generate. Recompiling all the shaders, again, in the distributed setup should be 4 times as fast, and so on and so on. The biggest gain was around convex hull generation. We've had cases where through visual data prep, we were generating collisions for like 5,000 meshes at the same time. And it would take a couple of hours, and now it's down to a couple of minutes. So overall, hopefully this helps with your processes in the editor. And last one that I want to talk about is the variant manager. We've made a bunch of improvements to the variant manager to help you with your different setups. So this is an example of a setup that's using the variant manager. So basically you can, for the same set of actors, you can have different variants and trigger them either through Blueprint or C++ at runtime to choose what setup you want in your project. Or if you're doing a product visualizer, you can have all your different variants and have a UI to toggle them. So the improvements that were made is around the thumbnails. You can now use any images that you want as a thumbnail. You don't have to create a U texture for that. We've also allowed to rebind your variants to different actors, so you don't have to start from scratch if you're deleting actors and adding new ones. And in terms of UX, you'll have access to the color picker if you're binding variants to a color property. And yeah, we have better support for your cameras, so you'll be able to control more camera properties through the variants. And we have an enhanced blueprint API. So if you're scripting to activate or deactivate variants, you'll have access to more information to make better choices. So yeah, that covers the enterprise use cases for 425.
Thank you very much, Jean-Michel. It's exciting to see some of the performance improvements. Next up, we're moving on to Marcus Wasmer.
Is it my turn already?
Sure
Sweet.
is.
Okay. So unlike my better prepared colleagues, I do not have awesome slide decks for everyone. So you just get to listen to me talk. So we'll go through a few items that I think are important. So for 425, one of the big things we have is initial support for next-gen platforms. So if you happen to be an Xbox Series X or PlayStation 5 developer, 425 will be the first place with some initial support there. While we're on the topic, I wanted to discuss a stream that there's been some questions on the forums in the community. There's a 425 plus stream that you'll see in GitHub, and I've seen some questions about what that's for. So what that's for is kind of continuous live updates on top of 425 for anything that's necessary for people shipping on next gen for launch this year. Just because it's unlikely that a full engine release will come out before then with everything that people need to ship. So that's kind of what that's for. The next thing to talk about is Niagara. So Niagara is finally out of beta and is going to be officially production ready in 4.25. So big congrats to that team. There's been a lot of effort over the last year to get that thing ready to go. Kind of as part of that, there are some pretty cool new features in Niagara that you should all try to play with. First of all, there's particle attribute reading data interface. What this allows any particle in an emitter to read data from other particles in that same emitter or from different emitters in the same system even. So with this kind of data sharing, you can do cool stuff like flocking algorithms or things like that. You can, let's see, what else is there? There's a really nice parameter panel UI update. So if you open the tool in 425 versus previous revisions, it's going to look a little bit different, a little bit closer to blueprint style, more consistent coloration. It's just a lot easier to read and parse what's going on. We worked with the audio team to do some pretty cool audio data interfaces for Niagara. So there's now like a spectrum analysis and direct access to waveform data. So you can kind of directly link your particle effects to the music or sound effects in your game now. So you can kind of make things pulse, or somebody can recreate the old like Winamp visualizers and stuff, which might be fun to do. And then finally, there's a kind of a cool experimental feature in Niagara that we're calling simulation stages. And this is a thing where you can set up your modules in such a way that all particles of a given module will update across all particles before running the next kind of stage of modules within a single frame. And this lets you do like, constraints and other things with a system. So you can create like fluid simulations, water simulations, smoke simulations, things of that nature. Like it's a real ability to start getting film quality effects out of the real-time Niagara tool. So pretty excited to see what the community comes up with when you guys get access to that feature. Another thing that's coming in 425 is ray tracing updates. So ray tracing is also officially out of beta in 425, production ready. It's been kind of a long road to get there for the team. Like we announced ray tracing, I think way back in 2018 with our Star Wars Reflections demo. Kind of followed that up with official engine support in 422. and then another demo in Troll, and now finally, after using it in production on Fortnite cinematic trailers for a while, we really feel like the technology is mature enough to go ahead and take it out of beta. And for this release, there's a few extra features, support for Niagara mesh emitters, for example, and support for a few other things I want to talk about in a minute, anisotropy and clear coat. So rolling right into that, there's some pretty big shading model improvements in 425. First off, anisotropy support is in beta. So this finally lets you be able to model, things like brushed metals and get the correct specular response out of them from the UV4 shading model. This works with the clear coat shading model and our default shading model, and it works properly for punctual and IBL lights, so like point lights, spotlights, directional lights, as well as reflection captures. One thing to call out here is it doesn't work properly on area lights yet. In that case, it falls back to the kind of the normal isotropic response. Still working on that one. If you do want to use it, it is a project setting because it requires an extra G buffer, and there's some performance implications. So we didn't want to just automatically turn that on for everyone if you didn't want the feature. But it really is a big improvement for visuals for certain types of materials. So definitely recommend trying it out if you've got like shiny metal surfaces in your games. The other shading model improvement is a new thin translucency model. So you can now do kind of physically correct colored and tinted glass in a single pass. This is really important because it's a real, previously it was a lot of work to set up like a piece of glass that actually looked correct. There's a lot of work in like making multiple surfaces with slightly different specular responses and stuff now. And now you can get it with one material and kind of one draw call. It's a lot more performant that way as well because you don't have to mess around with extra draws and extra overdraw. And then kind of as mentioned a little bit earlier, improvements to the clear coat model that often gets used for like car paint has been improved, mainly around directional lighting. So you should get a much more correct directional response from your lighting on clear coat than you would before. The previous model was more optimized for environmental lighting, but we found, doing collaborations with various car companies over the years that the directional response needed an upgrade. So you'll see that in this release as well. Let's see. So carrying on with the shader theme, there was a big refactor to kind of the low-level guts of how materials and shaders are loaded for cooked projects. The main improvement here was for load times. So material and shader data is now like cooked all the way down, basically to pointer fix-up format. Like you can almost read this stuff directly from disk into memory, do a little bit of pointer fix-up, and the data is good to go now. So it should be a nice improvement to load times for any content that was getting in a bound loading materials. So I'm kind of stoked about that one. There's also like a set of other various load time improvements in 425 as well. Like I guess for some projects you could see, anywhere from like a 5 to 15% improvement in load times, literally just from updating to 425 and not doing anything else. Results may vary, kind of depends on content, what you're bound on, but overall it should be a win for everybody. Another big change is a complete redo of our eye adaptation kind of auto exposure system. So the older system had multiple modes that behave somewhat differently. So there was like a histogram mode and a basic mode, and they kind of had the same set of parameters, but not really unified response. Like you would change from one system to the other one and get like a completely different result. So we spent some time unifying those things so that kind of all the parameters mean the same thing across the different models. There were some improvements in the visualization of what's going on in your auto exposure. But kind of the key thing to call out here is that it kind of is backwards compat breaking. So when you load your project up in 425, there's an upgrade path that'll automatically upgrade you to the new stuff and do like a best fit possible of the old parameters to the new parameters. but you're not guaranteed an exact match in look. So I'd recommend, if you do see like differences in your kind of exposure and auto exposure response for your project, there will be a tech blog linked in the release notes for 425 when they get released.
I just linked it in chat as well.
Oh, you linked it in chat? Thanks. Yeah, so take a look at that one. And if you have any questions after that blog post, just ask us. And finally, auto exposure is now available in the mobile renderer, although you have to be using the mobile HDR kind of project feature. And then speaking of mobile, we upgraded our default rendering feature levels for mobile. So OpenGL ES 3.1 and Metal 2.0 are now the default feature levels. This just lets us have kind of better parity of feature set across platforms and devices. You can do preview of these things from the editor, so you don't have to deploy the device to get an idea of what your content's going to look like. And then another thing, a major thing to mention here is that we did remove OpenGL ES2 support. And that really lets us clean up a lot of restrictions in the code and a lot of maintenance code that was slowing things down and making it hard to add new features to the engine. So I really expect that to help the mobile team over the next year upgrade rendering on the mobile renderer. Let's see, another cool thing is hair and fur rendering updates. So quite a few improvements on our new strand-based hair renderer in 425. This is something that debuted in 424. It's like a high quality, if you haven't seen it, you should check out the release notes from 424. It's really great. You get almost film quality level strand-based rendering and simulation. Simulation is hooked into chaos, as opposed to like your more standard card-based hair rendering that you would usually do for real-time console games. The full list of the improvements will be in the release notes. It's mostly around how you're dealing with the groom. But there's also, there's already some really cool projects from the community. If you haven't seen it already, there's a pretty funny one. If you Google for, I think it's UE4 Uncle Harry. It's a pretty nice, it's just a guy that's completely made of the strand hair and dancing around. It's pretty cool. Let's see. As far as getting the hair to work on, current gen console and lower end PC devices, the team working on hair is now starting to do some work on automatically converting the strand-based hair partially to cards, so that you can author just the one asset, but still be able to bring it to a performance level that you could ship on other devices. So that's still kind of R&D work. It's not clear how much we can get done 100% automatically and how much artistic touch-up will have to be done after the fact, but we're definitely giving it a go. And then I think lastly from me are improvements to our new sky and atmosphere model, which also debuted in 424, where you have a much nicer physically based sky, and that you can zoom out to all the way to space and render little microplanets with the atmosphere. It's really cool. And that model scales all the way down to mobile devices. So there's no reason not to use the new model if you're not using it already. Definitely recommend using it. Improvements for this release, though, are you're going to get nice shadowing from the sky atmosphere model. So you're going to get nice God rays from trees, or if you've zoomed out to looking at your planet from space, if you've got big mega structures, sitting on your planet, you'll see nice shadowing from the atmosphere. So definitely recommend just everybody go ahead and move over to the new model. So yeah, those are kind of my big topics. Anybody have any commentary on those?
Just that, Marcus? Jeez.
Just that? I know. I saw James.
What have you guys been doing?
I saw your face when I started talking about the card, the cards on the account.
Well, that's a really hard problem. I mean, yes, as you say, we're looking at it, but it's a tough one.
Yeah. Thank you very much, Marcus. I do know that a couple of you had to zip out in a little while for a meeting, but I think we have time for a couple of questions. All right, let's start off with chaos. There were a couple of questions regarding that. I know some of them we won't be able to sort of talk about. We don't have a Michael Lentin on here today, but there were a couple of questions regarding sort of when and if we've announced when chaos will be able in the binary builds of the engine.
I don't think we've announced that yet. I mean, we're basically working. There's a few things we need to still get exact parity for. We don't want to make sure anyone have a worse experience when they switch over their projects. So yeah, we're just working hard on that. But I don't think we've sort of have an official date for that yet.
No, not as yet. But so you'll still have to compile it from source if you're using a Chaos.
Yeah. So in 425, it's the same situation as 424, where you'll need to get the source and compile it, because it's not just a plugin. It is something that's really core, and you have to recompile to switch physics engines. So yes, to switch it on, you'll need to recompile. But we're obviously working to the point where that'll just be the default, and everyone will be using that.
And I think it's worth pointing out there that what James is saying is that we are getting it to the point where everything that you're currently using in UE4 in terms of physics will just be replaced with Chaos, and so that when you hit, go simulate or enable simulation on mesh, it will actually simulate and fall, and you're not working with the current sort of component setup that is currently in the engine. There was a question if we have any info about server authoritative Chaos physics.
Yeah, so this overlaps. I saw there's a question about the network prediction plugin as well. So this is sort of an R&D effort that's going on. As people who are familiar with Unreal might know, our character movement has built-in client prediction rollback networking, so it feels really responsive. It's sort of the standard way we've done movement for a long time, but it only works on characters. And so we have started an initiative with this network prediction plugin to make that more general, so that it's easier to extend that and use that style of sort of rewind, replay networking on things other than characters. And one of the things we're looking at there is physics, and one of the nice things about owning our own physics engine is we can now integrate it much more closely with other systems. And so that's something we're looking at. It's a really hard problem, how you might roll back and re-simulate things when you get corrections in the physics engine, but it's something we're looking at. I think network prediction, where we do think we'll go into production at some point, and we're looking to sort of shift things like character movement over to that is the hope. Things like physics is much more at the research stage, because it's an interesting idea, but there's some big challenges there as well.
And then moving on to, well, actually continuing with Chaos, someone's wondering, will Chaos be compatible with ARM and Linux?
Yeah, I mean, Chaos will have to be, will work on all the platforms that the engine works on, because like you said just now, the plan is that we'll be switching everyone over to that once we're totally confident that it's ready. So absolutely, it'll work on all the platforms. And again, that's one of the nice things about owning all that code, is it makes it easier for us to port it and optimize it for all the different platforms and really get the most out of it.
Are there any plans to have more than one new Sky component per scene in the long term, of course?
More than one new what, sorry?
Sky, the new Sky component.
Oh, right. That's probably a Marcus thing.
Yeah, no plans at the moment. Yeah, not saying it'll never happen, but it's not something we're working on.
There's a cinematics question. The user is wondering if multiple passes export for sort of AO, ID, etc. will be available.
Yes, we have exports for some passes right now, and we're working on adding a lot more passes. We're working with the cinematic teams and seeing what is the most important passes for them to get. So for 425, we have basic passes. For 426, we'll have probably everything that is required for normal compositing.
Another question for you, Simon. One of the users chat was wondering if they could edit meshes like this at runtime when we were showing the little bridge sculpt.
Good question. The modules to handle the modeling are available at runtime. However, I'm not sure about the UI if we have anything for that at runtime. I don't think so. But you could extend it to do it at runtime.
It would have to be done custom, though, as far as I know.
As far as I remember, yes. There's nothing already for this.
Question for you, Jean-Michel. They were wondering if USD is considered stable in 425?
It's considered beta in terms of our experimental beta and release status. So yeah, we support most of the features to load USD files, and the main thing is that the USD ecosystem is still moving quite a bit. So it's going to take a couple of releases before we get out of beta.
Someone was curious if we will get project settings to adjust thread limits for shader compilation.
Sorry, one more time?
The question was, will we get project settings to adjust thread limits for shader compile?
I think that there are already console variables you can set, although they're not exposed like in the project settings UI. But there are some console variables you can set in your INI files manually to control that. Off the cuff, though, I don't remember exactly what they're named. Probably if you ask on the forums, somebody can point them out.
Let's see. There's another question regarding chaos just came in. They're curious, what solvers are you using for the physics engine?
I don't want to misspeak and get details wrong there. So maybe that's a good question for a Michael Lentine or someone else from the physics team question in the future. But I believe it's position based, but there's a lot of cleverness in there. So it would be good to maybe get someone from that team in to talk in more detail.
We will definitely do another stream on chaos, hopefully this year. Try to get Michael Lentine back on the stream. Those were all the questions that were relevant towards 425 that we received in chat so far. Is there anything else one of you would like to add?
I'll add a couple of things. I saw some comments scrolling through the chat, I think, while I was talking about the shader loading improvements. I just want to point out that that does not mean that shader compilation will be any faster. It's more like once you've cooked all your content for release, to your players, it'll load faster. But compilation speed is unchanged from that. And there was, I think, one question about GPU light mass. The state of that is, if you look on the dev rendering stream in GitHub, you'll find kind of the first check-in of that. It's definitely an experimental state right now. I think it's not going to be production ready or anything anytime soon. But if you want to check it out, you can sync the dev rendering one and give it a whirl.
Another question that came in was, is it possible to add a custom shading model via plugins?
It is not possible to add a custom shading model via plugin. No.
Let's see. This question came in regarding, will UE 4.25 adhere to Apple's changes to remote notifications?
I'm not sure.
Might be able to follow up, perhaps.
Yeah, that'd be one probably for the mobile team. I know that there were some changes to support various requirements around Apple Arcade. So if it was part of those requirements, it probably is in there, but I haven't heard of that one specifically.
A few more questions coming in here, probably because we said we were about to wrap up. How is performance in 425 with ray tracing? Is it improved? Is it the same?
Performance is improved, but I mean, you're not going to see like an order of magnitude change. It's more like incremental improvement in a couple areas.
All right, I think that was it for questions, and I do believe that y'all are going to make it in time for your meeting, so that's great. I'd like to thank everyone for joining, taking the time out of your day to come here and prepare a little bit of presentations for us. It's been great. Chat's very excited about some of the changes in 425, and I have seen a lot of questions regarding release dates, and we generally do not announce that until the release is actually live. And so just stay tuned. It is coming soon, TM. Next week, we will have the team from Sumo Digital coming to talk about the journey of the game Spider that was released on Apple Arcade. It's exciting. The team is very excited. They've prepared quite a bit of content for us to show how they went from sort of start to finish of shipping the game. That said, I think it's time to wrap up. And so once again, let's everyone say goodbye to chat. And I hope to see you all next week again. It's been great. Bye, everyone.
All right.
Thanks
everybody.
Bye-bye.
Yeah.
Everyone.